And we'll move on to our next speaker, who's Denise Sanger from Basin.
Good afternoon, everyone. I'm going to talk to you about assessing salt marsh vulnerability techniques in South Carolina and the implications for management. This is a joint project with the Basin and the North Inlet Winyah Bay near. So if you look at the center image in South Carolina, and you can see North Inlet Winyah Bay is located to the north of Charleston, and you can see the reserve boundary in red, as well as the approximate location of the wetlands and water level site, which I'm going to call Will, just to make it easier. And then if you look down south, you can locate the Basin near, and you can see our watershed, or excuse me, our near boundary, plus where our Will site is. And so we both had active Will sites for many years, as well as we participated in the Drone the Swamp effort for the Southeast. And that really expanded our capabilities using the unmanned aerial systems, UAS, or drones, as most people call them. And so what we're going to do in this project is really use all that near monitoring, as well as look at national products to better inform marsh vulnerability metrics at the local project scale for South Carolina. Well, why is this important? In South Carolina, we have 350,000 acres of salt marsh, which is about a third of the Southeast. And so we know a lot about some locations like our Will sites, but we then also have huge areas where we don't have the knowledge we need. And so we're starting to see much more interest in beneficial use of dredge material. And whether or not we need it on our marshes is sort of our specific question at this point of, trying to figure out where do we environmentally need sediment. And so we heard all about MARS. And so here's the MARS table again. I've highlighted North Inlet and the Basin because we both participated. And you can see that, we really are in that yellow area of overall resilience. So not thought to be highly resilient, but also not thought to be vulnerable. If, however, you look at the USGS unvegetated to vegetated ratio, or UVVR, sort of that national product that was developed, and you look at North Inlet on the right, the Basin on the left, and where our wetland and water level sites are, and you draw that 0-1-5 line, right? Anything that's a darker orange to red is thought to be at that extreme end of the scale and vulnerable from a drowning perspective. So when you look at this, right, and Eric mentioned this earlier, right, we look terrible, and every marsh in South Carolina is in trouble. So we want to better understand that. And as has been highlighted, there are questions in the Southeast as to how well that threshold, as well as sort of that national product looks. And a couple of the things that have been highlighted really are, we are Spartina alterniflora dominated. And so our marshes tend to be sparser than some marshes in the Northeast, as well as around the country. But we're also concerned about tide. So this is a NAPE image. This is 1 meter scale, and this is a vegetation index, the NDVI. And this is actually south of our the Basin in the Port Royal Sound estuary. What you can really easily see, right, is that we have three, sort of the top and the right image are very bright orange, and our marshes look, again, terrible. In comparison to the lower two images, and the left is, you actually see that, right, we don't look quite so bad. So I went ahead and pulled when these segments were flown, and they were flown at different times. The orange segments were flown at high tide, which is a tidal amplitude of about 2.5 meters. So lots of water on the marsh, and so we look like we're flooded out. And then the two lower images were flown during an ebbing tide at about 1.5 meters. And so we look a little better, but we still have water on the marsh. If you just look visually at a couple of images, the image on the left, this is our well site in the ACE Basin. You're just looking from two different orientations. One, you're looking upstream, essentially, and the other, you're looking downstream. The lower image was collected at high tide, and so you can see, right, how much water can end up on our marshes and how they look almost flooded out, right? You see very little Spartina grass or green if you were looking at the NDVI. In comparison to the image on the right, where it's low tide, this is sort of peak biomass season, but you just don't see that same sort of flooding out or significant loss of marsh. So what we're focusing on in this study is scale, resolution, and then a whole suite of different metrics. So we've heard about some of these already. And so if we think about scale, this is just the example for the ACE Basin. Same thing will happen in North Inlet. And you look at our wetlands and water level site, which is right here with that orange arrow again. It's about 2.6 hectares of marsh, right? So really small scale. Then we have an eDNA watershed that surrounds our site, and that's about 700 hectares of marsh. It's the yellow boundary. And finally, the Huck 14 is about 1,700 hectares of marsh. So all of these different metrics, or some of the different metrics, can be looked at across these various scales, right? So very small to bigger to gain perspective. Resolution is also important. And so, right, we have lots of information from our well site, plot level, sets, as well as water quality to look at turbidity. So very, detailed information. We also have UAS imagery. And so we fly to obtain about a 2-centimeter resolution. This image up on the top image is UAS imagery. And in the ACE, we fly about every 2 years, but Eric in North Inlet actually flies every month. Ooh, gotta go quick. But we always fly at low tide, right? So we're always trying to make sure we have water off the marsh. The image over here on the right is actually 1 meter NAPE imagery. It's flown every 2 years, but there's no choice, right, of trying to obtain water off. So we'll just note that. And then Planet Scope, which is satellite imagery, is 3 meters. It's flown daily, so we can go in and actually choose low tide imageries. And then Landsat, which is what the level at which the 30 meter is what the UVVR sort of national product is. So luckily, everybody else has talked about these metrics. And so, right, looking at a suite of metrics at those different resolutions, as well as those different scales at each of our sites, is what we're going to hopefully achieve in the project. And our outcome really is just sort of that initial suite of metrics that's useful in determining the status of our salt marshes at the local project levels. People are pointing to UVVR, the national product, and saying that marsh needs sediment. We don't know that that's true. So how do we begin to fill in the information? And then ultimately, right, we'll hopefully get some additional funding to be able to test this over additional areas. And then I would love to see South Carolina have a marsh monitoring effort at the state level. So hopefully we can then scale up to larger scales. And so this is the North Inlet wetlands and water level site.
Excellent. We have time for a quick question if somebody wants to hop off mute or type it in the chat. Denise, I'm curious if you've looked at time series for these marshes where Mars tells you one thing and UVVR does another. Does it look like they've been falling apart over time?
No, it does not. Our marshes look pretty similar most of the time. And I forgot to point out in the UAS imagery, you can really see in that upper image how sparse, you know what I mean, and how much mud just naturally shows. So I think it's just a different landscape. And a lot of times if we have marshes that don't have vegetation, then we have oysters, like interspersed in them. So again, is that bad or good is the question.
Well, thank you. And if you think of more questions for Denise, type them in the chat.